Okay, so today we are learning the square root function. Okay, first of all, we should understand what is a square root function. Like, what formula does it have? So for hyperbola, we have 1 over, like something over a linear, a constant over a linear. For a truncus, we have something over linear squared. Okay, something over linear squared. That's a truncus. And then for square root, well, definitely we will have the square root sign. Okay, the square root sign. But the inside must be a linear. Okay, the inside must be a linear. So the inside, if it's not a linear, well, we will learn the circles later. Like a lot of students confuse with semicircle and square root function. They can't like decide, oh, whether this is a quadratic, whether this is a semicircle or whether this is a linear. So square root. For a square root function, you must have a linear in the square root. Well, if it is a quadratic in the square root, well, that's a semicircle. That's not a square root function. So we'll talk about more about that when we reach the content of semicircle. But we need to understand we have square root function is a square root and like a linear under that, and we can have some constant, and we have some constant adding and times with that. Okay, so first of all, if you have something that looks like this, then that's a square root function. Well, a can be positive or negative, k can be positive or negative. The linear can be an increasing or decreasing graph, doesn't matter, but it must follow this formula here. Okay, let's have a look at the simplest square root function. That's y equals to square root x. Okay, the linear is the x. The graph looks like this. Okay, the graph looks like this. Let's have a think. Let's have a think about something about the if you can think about if that's y equals to square root x. Well, I know we haven't really learned the transformation yet, but have a think about like the simple idea about like reflection. What y equals to negative square root x will look like? Which axis is get reflected? X or y? Like, is this graph is reflected by? Okay, x-axis. Okay, you negative everything. So with the same x value, you have the negative y value, which means it's reflect down. So you can draw it here. So that's the reflection graph. That must be y equals to negative root x. And then let's have a think. What's y equals to root negative x looks like? Which direction you have? Reflect by y equals to root x will be reflect by y-axis. So, well, you have a symmetrical graph going that way. That's y equals to square root negative root x. And then the last part must be reflect by both directions. If you have a negative outside and negative inside, you reflect twice. You reflect this twice. So we'll have this direction. Well, I'm not really make it symmetrical, but somehow it looks like this. Y equals to negative root negative x. Okay, so that's the full direction. I will use that later. Okay, that's enough to just think about the graph first. And then let's have a think about the most original graph, y equals to root x. Let's have a think about that shape. There's the endpoint. Okay, key features. For truncus and hyperbola, we have asymptotes, 2 asymptotes. Okay, and then it's approaching to the asymptotes. But for this one, the key feature, we have a new key feature now. Before the linear or quadratic, we don't have this. It's called endpoint. You graph like without restricted, like without I say, well, this graph should be from -2 to 1. The graph automatically got a stop point. Okay, it's not continue forever. So it stopped at the point 0, 0. Okay, stop at the point 0, 0. So why it will stop? let's have a think about the reason why the graph will stop. Why I can't have -1, -2, -3? What's the reason? Yeah, it's a square root, that's true. So y equals to square root something. The something can't be a -4. So therefore, it can only stop at 0. The last value this function can take is 0. The minimum value this function can take is 0. So square root 0 equals to 0. That's the last point this graph will have. That's why there's an endpoint. Okay, that's why there's an endpoint. So very similar reason, like do you remember how we find the implied domain when this is a square root? We make everything under that to be greater or equals to 0, right? We make everything under that greater or equals to 0, and then we solve for x. So let's investigate this graph, y equals to -√x. If we want to think about the domain, what we'll do, I will say -x will be greater or equals to 0. Then x will be less than or equals to 0. That's why the first point this graph can take is 0. And all the negative value is fine, because you negative the negative value again. So that's why you have the graph start, finish at 0, and then all the way to the negative side. Okay, -infinity to 0. So that's like, just talk about a little bit about the domain. So we need to find the endpoints. Okay, the most important thing for a square root function is to find the endpoint. Okay, to find the endpoint. Okay, so then let's have a look at the domain. I'm talking about y equals √x. The domain is r plus union 0, or I will prefer to say 0 to infinity. Okay, 0 to infinity. I can find the domain by looking at the graph. Yes, it starts from 0. If you go vertical line, the first point you touch is 0, and then all the way to the right is fine. So 0 to infinity. You can also find the domain by thinking about this equation and use the implied domain method. Like something under the square root must be greater or equals to 0. Therefore, x must be greater or equals to 0. You also have 0 to infinity. And the range is 0 to infinity as well. So if you go horizontal check, so the first point to touch is the endpoint 0, 0, and then all the way up is 5. Just something I want to mention. This is an increasing graph, but it's a slowly increasing graph. Like quadratic is an increasing graph as well, but it's like very rapidly like grows, like this. But this one is growing in this way, like it's a more flat way, like slowly grows. So do not mix up like the shape of the graph. It needs to really show square root function with a slowly increasing or decreasing graph. So it's that direction. Okay. That's the basic shape. So we will have a general equation. Well, I already mentioned the general equation. That's the general equation. Okay, I have already mentioned the general equation. That's the general equation. We time something outside the square root, and we add something outside square root, and under the square root that must be a linear. Okay, under the square root that must be a linear. Okay, let's talk about the steps to sketch this graph. Let's talk about like this step. The first step, it will be find endpoint. So the endpoint, y value must be k. Okay, it's the constant you add or subtract. Like the k value must be the y value of the endpoint. So the x value of the endpoint must be solved linear equals to 0. Well, the linear in under the square root, you solve that equals to 0. I don't want you to see like factorize and x minus h and then h is the endpoints. It's too hard to do that. So the basic idea is you make the square root equals to 0 and you see the endpoints. So solve the linear. For example, if under is a 2x plus 4, then you solve 2x plus 4 equals to 0. Then x equals to -2 will be the endpoint. Okay, x equals to -2 will be the endpoint. Is the point will make the square root, like under the square root equals to 0. So that gives you the x value. Okay, you get the x from here. And y is just k. That's the endpoint. Okay, we'll label the endpoint. Second is very easy. Choose the direction of the graph. Choose the direction of the graph. Well, see above. So the full direction, that's the full direction. Okay, which direction we'll choose? We just see, we don't need to care about the value. We don't need to care about the value. What we need to see is, well, ask yourself two questions. Any negative in front of x? Any negative value in front of the square root? You look at two places. Look at the x. Is there any negative values? And then you look at the square root. Is there any negative values? And it's exactly the same shape as the negative, where you got the negative. Well, if you have both negative, like negative square root, negative x, then you have the red left-hand side corner, like the red graph. If you have outside negative, you have the right corner here. If you have inside negative, you have the left corner there. If you have both positive, you have the most original shape. So you will select a direction. So you know your endpoints, and you can select a direction either this way, this way, this way, or this way. After select direction, see if there's any xy intercept, if possible. Well, sometimes you don't have xy intercept. Sometimes you have 1, sometimes you have 2. So after you sketch the rough shape, you can see, do we really have xy intercept? Okay, very easy for square root function. That's the basic 3 step. And one more thing I want to say is, when you're trying to find the domain, you can go 2 methods. Either look at the graph. After you sketch the graph, you can look at the graph and then decide what is the domain. The second one, okay, that's the domain, that's the dome. The second one, you will solve the linear under the square root greater or equals to 0. You solve the linear under the square root greater or equals to 0. Well, same reason as before, implied domain, you need to have positive or 0 values in the square root. So you solve the linear, well, you have x something, you can solve out the domain. Second, if you want to find the range, well, range, you can only find that by graph. Okay, you can see the range. I don't want to memorize. You can memorize my rule there as well, but like I think it's just too complex. You can just see the graph and then see the range. Okay, look at the graph and then see the range. Well, it will only be 2 cases. Either it's from the endpoint to infinity, or negative infinity to the endpoints. It's just like 2 cases. Okay, just 2 cases. From the endpoint to infinity, or negative infinity to the endpoint. Y value of the endpoints. Okay, let's just do the first one. Well, first step is we will find the endpoints. Okay, to find the endpoints, we solve x plus 1 equals to 0. X equals to -1. And the y value is -3. So -1, -3 must be my endpoint. -1, -3 must be my endpoint. So here's my endpoint. You must label your endpoint. You must label it. Okay, label means label as coordinates. Even if it's on the x-axis, you still need to label -1, 0, like label as a coordinate. And then the next thing is we will select a direction, like positive direction or negative direction. We'll select a direction. So we can have a look. We have positive x and positive square root. So we will have a most like original shape. So it will be this. Well, I'm not finishing it because I haven't found the xy intercept. There's xy intercept as well. You just like use your pen to see, do you cut the x-axis or y-axis? You don't need to sketch it because I can just clear it really easy. So it's somehow like this shape. So I will solve for it. When x equals to 0, y, well, I'll say f0. Use the notation. f0 equals to square root 1 minus 3. That equals to negative 2. So 0, negative 2. And then when fx equals to 0, square root x plus 1 minus 3 equals to 0. Square root x plus 1 equals to 3. X plus 1 equals to 9. X equals to 8. I just want to change my scale a little bit. It's quite far away. So I have negative 1 and negative 3. And then I have negative 2. 0, negative 2. And I have eight. That's 8, 0. So the graph looks like this. Well, it's very flat. It's actually very flat. But like label your endpoints xy intercept, obviously. So negative 1, negative 3, 0, 2, and 8, 0. So it's continue all the way to that side. Then, like if we talk about the domain. Okay, what's the domain for this graph? Yeah, how's the negative 1? Inclusive? Yeah, negative 1 to infinity. And what's the range? Inclusive to infinity, all the way up. It like even though like you see this graph is very flat, it's not an asymptotes question. It can keep going to infinity because think about if you have a million, square root a million, you still have quite large values. It's just like grow very slowly, but it will grow to infinity anyway. Like it can keep going up that way. Or you can solve the domain by, well, when I see this question, I will say x plus 1 must be greater or equals to 0. Therefore, x must be greater or equals to negative 1. So x belongs to start from negative 1 to infinity. Start from negative 1 to infinity. So I can see the domain by both methods, by looking at the graph or by solve it. Okay, let's have a look at the next page. Fx equals to 1 minus 2 square root x plus 1. Fx equals to 1 minus 2 square root x plus 1. So for this question, we'll solve the well, I will make the rearrange the equation first. That's negative 2 square root of a linear and then plus 1 plus the constant. It's just like easier. If you can see it, you don't really need to do this. So let's find the endpoint. X value of the endpoint will be the inside equals to 0. X equals to negative 1. Well, why y equals to 0? Well, just reasoning a little bit for you. Make it equals to 0 is because the last point you can take is 0. Either to the left or to the right, the last point must be the thing in the bracket in the square root equals to 0. So that must be my last point. Okay, that must be my last point. So if everything in the square root equals to 0, square root 0 is 0 as well. So times with the constant just becomes 0. So you're only left with the constant. So that's why that's the y value of the endpoints. Okay, that's the reason. 0 must be your last point. Like everything equals to 0 must be your last point. So the endpoint must be -1 and 1. So that's the endpoint. Okay, -1 and 1. Let's label that. This point is -1 and 1. That's the end point. We know that already. And then the next thing we'll look at is the direction. Okay, we look at the x. There's a positive x. Then we look at the y. No, the thing in front of the square root. That's a negative. So we have one negative. Okay, if you have one negative, it's the negative outside the square root. Okay, that's the square root x. If you negative outside, that's reflect in the x-axis. That's the negative square root. So you follow that shape. So if you follow that shape, the graph will looks like this. You still have xy intercept. Okay, you still have xy intercept. So we look at for xy intercept. When x equals to 0, f0 equals to 1 minus 2 times 1, and that's -1. So 0 minus 1 is here. So we have a really small negative x-intercept, then we can see that. So when fx equals to 0, 1 must be equals to this. A half equals to this. Let's go that way. So a quarter equals to x plus 1. X equals to -3/4. So that's -3/4, 0. You square both sides. When you have square root, you square both sides. So the point is here. So you can see this one is actually it's not as flat as the previous one. You have this shape. So here you have this -3/4, 0, and that's 0, -1. So the domain must be start from -1 to infinity, and the range must be start from -infinity to 1 inclusive. It's all by the graph. Or you can solve x plus 1 greater or equals to 0, x is greater or equals to -1. So the domain is -1 to infinity. Okay, question 3. I want the linear inside, so I want the inside is mx plus c form, so I will arrange this as well. Fx equals to negative 2 square root negative x plus 5 and then plus 1. Okay, so we find the endpoint first. Well, to find the endpoint, we'll make the inside negative x plus 5 equals to 0. 5 equals to x. So the endpoint must be 5, 1. And the endpoint must be 5, 1. That's the endpoint. Next thing is select the direction. We have negative x. We have negative square root. So that's both negative. Both negative will be reflected twice. Okay, reflected twice. Okay, this is the original graph. Reflected once. You have that. Reflected twice. You have that. Okay, this one. So 1, 2, 3. So we have this direction. Well, again, we have xy intercept. If we have xy intercept, we say when x equals to 0, f0 equals to 1 minus 2 root 5. This must be a negative number. You see that? That must be a negative number. That's a square root 1. You minus the square root 20. That's definitely a negative number. Well, I don't know how large is that, but I know that's a negative. So we just need to make sure it's a positive or negative value. So we have a negative. And it's quite negative. I'll just make it here. Just make it here. So when fx equals to 0, 1 equals to 2 square root 5 minus x. Half equals to 5 minus x. A quarter equals to 5 minus x. X equals to 5 minus a quarter. X equals to 20, 19 over 4. It's quite close to 5. It's only 5 subtract a quarter, so it's just a quarter away from the 5. So which is here. Okay, if you connect the graph, that will look like this. That's 19 over 4, 0. And that's 0, 1 minus 2 root 5. Do not simplify it. Do not use calculator to simplify it. When you label it, unless the question tells you to give how many decimals, otherwise you all keep exact xy intercept. Well, the point you label unless the question tells you to round it, otherwise just leave it as the exact form. Yes? No, it's just roughly, right? Just rough. Well, you can have a think. 5 is square root 5 is 2 point something. 2 point something. Well, I don't know. I think it's 2.3 or 2.4. I can't remember the value. So it's just 2 point something. So times the 2, that will become 4 point something. So 1 minus 4 point something is negative 3 point something. So it's just roughly about negative 3 something. Yeah. So just roughly, you don't need to really sketch it to that scale. Well, it will be good if you can remember the value of square root 2, square root 3, and square root 5. Well, I can remember the first two. That one is 1.414 something. Root 3 is 1.732, and I think root 5 is 2.358 or something. I think it's 2.3 to 2.4 around that value. So just remember 2.3 to 2.4. So if you can remember that when you're trying to see what's actually where it should be, it will be easy if you know those three values. That's the common ones. Well, I won't ask you to remember square root 17, like that's no sense, not make any sense. So root 2, 3, and 5 are the common used value. So if we think about the domain for that question, that will be negative infinity to 5 inclusive. You can achieve that by solve 5 minus x greater or equals to 0, 5 greater or equals to x. That's x less than 5. So negative infinity to 5. And the range of this graph must be negative infinity to 1 inclusive. Okay, last one. Well, again, rearrange that a little bit. That's square root minus 2x plus 4 and then plus 3. So solve endpoint. Negative 2x plus 4 equals to 0. 2x equals to 4. X equals to 2. So endpoint will be 2, 3. Okay, so you find endpoint, that's 2, 3. And then we can just sketch it on this. So 2, 3 for the endpoint. And then we'll see the direction. Okay, we have a negative x, but we have a positive outside. So it's only one negative inside. If that's the square root x, you negative the inside, that's reflect in that direction. Okay, reflect in that direction. You negative the x is reflect in the y-axis. Well, x equals to 1 and x equals to minus 1 will give you the same value. So that's why it's reflect by the y-axis. So we will have this graph. That's number 1, that's number 2. So we will have that shape. We can see there's no x-intercept, which is really nice. Okay, there's no x-intercept. So when there's no x-intercept, I only have y-intercept. I'll say f0 equals to 3 plus square root 4. 0 times 2 is 0. So f0 equals to 5. Zero, 5. Okay, so the graph looks like that. Okay, just summarize on what we learned today. Okay, we learned how to sketch a square root function. What is a square root function? It must be a linear under the square root. Can't be any other thing under the square root. It must be a linear and the square root, and you can times something with the square root, you can plus something with the square root. And then we go through how to sketch for it. We will find the endpoint first. So the k value must be the endpoint, y value of the endpoint, and the x value is solved by the linear equals to 0. We solve out that. And then there are 4 directions of that graph. Okay, I have shown you individual, like each of that, like the 4 directions. We have the see the positive and negative, choose one direction, and see if there's any xy intercept. If there's any, you need to solve for that. You need to solve for that. And then we will consider about the domain and range. Well, the last thing we will consider will be the domain of that one is negative infinity to 2, and the range is 3 inclusive to infinity. To infinity, so that's the domain and range. Or we can solve it by we can solve by 4 minus 2x greater or equals to 0, and we can have 4 greater or equals to 2x, x is less than or equals to 2. We can solve that as well. So that gives you negative infinity to 2. Okay, so homework will up to exercise 4C. Okay, exercise 4C.